afternoon, ladies and gentlemen. My name is Dr. John Belkowitz, and we got a Math Monday. We're jumping back into the series that we used to do early on to make this social media effort, a little bit more organized, and it makes it a little bit easier for us to really distinguish our content. So we're starting back up with Math Monday! And what we're focusing on is we've been running these webinars lately, these awesome webinars. We did one on a batch ticket class where we looked at how to use a batch ticket to identify the aggregate to paste ratio or the paste to aggregate ratio. We use a paste to aggregate ratio in lieu of the other to identify, is this mix going to be creamy and dreamy and easy to finish, or is it going to be a bony and bony and nasty mix? So dive into this with us. Let us know if you have any concrete questions or concrete concerns. Really hope you like it. I'll be right back. I want you to look at and I want you to understand the math behind how can we see this bonier mix on paper. And to do that, I need you to work with something called the paste to aggregate ratio. And what I mean by that is if we look at our paste content and divide it by our aggregate content, and this is both, on a volume basis here, we can come up with this ratio that could help us identify the likelihood of that concrete being creamy and dreamy and easy to close up versus if it's out of a certain range, and this, of course, depends on your mixes, and you'll have to identify it for, who you're working with in your area. But if it's outside of that range, we're going to start having problems. So we do that by first taking certain assumptions. First of all, the first assumption is that our end user was designing 27 cubic feet in a cubic yard. It's called our absolute volume method. And per ASTM C94, they got to do that. And the testing technicians on the job site can even give you that information as we talked to previously. And please bear in mind, one of the biggest assumptions is this is a prediction method. It doesn't mean it's exact. It has some error to it because inherently we're working with error in the system. So the next thing that we have to do is identify some unit weight stuff here. And again, this is math. And when we say that we're designing for 27 cubic feet in a cubic yard, bear in mind that there are there's weight per unit volume for every material, for the sands, for the cements, for the rocks. And unless we have those, we're going to have to make some assumptions, which again will invite some error. But bear in mind, this is still a prediction method. This is an educated guessing method. And we're out in the field. We have to be able to do this fluidly. So practicing it in the office, at night over, at the dinner table is imperative. Now I'm taking the information that I assumed and I'm using the information that's on my batch ticket, my cement, my ag, coarse and fine ag, my water content, my water cementitious ratio, all of that to start calculating. And the first thing that I do is get my material volume calculations. So I look at it for my cement, my coarse ag, fine ag, water, even my air. And the way I do it is, let's say for my cement, I take my cement weight, my 750 pounds per cubic yard, and I divide it by the unit weight of cement at 196.6 pounds per cubic yard. Now, again, you can assume this, or if you have the mill report, you'll see specific gravity of cement to be 3.15. So I take 3.15, I multiply that by 62.4 pounds per cubic foot, which is the unit weight of water, to get this 196.6. And when I do that math, I come out with a volume of 3.8 cubic feet. That means in this cubic yard of concrete, I have 3.8 cubic feet of cement out of my total 27 cubic feet that I can use. And I do that same calculation for my coarse aggregate, and I find that it's 8.9 cubic feet. My fine aggregate, I find that it's 9.3 cubic feet. And then for my water content, I find that it's 4.2 cubic feet. Now, the way that I find my air is I take my assumed or my measured value, 4.5%, Again, you can get this from the technician, get this from the batch ticket itself sometimes. And I multiply that 4.5%, so 4.5% over 100. I multiply that by 27 cubic feet in a cubic yard to get 1.2 cubic feet of air out of my 27 cubic feet in my cubic yard of concrete. Now, with all that information, I add them up. I add up my paste, water, and my air to identify my paste volume. I add up my rock and sand, my volumes, again, to get my aggregate volume. Now, if you have 3 types of cementitious to make your binder, then you do 3. If you have 4 types of sand, 2 coarse aggregate and 2 sands, then instead of just using 1 rock and 1 sand, you would do 4. And if you have 8% air, you would use that value. But ultimately, when I get these values, I divide my paste volume by my aggregate volume. And when I do that, I get a value of 0.50. So my total for my paste volume was 9.2 cubic feet. My total for my aggregate volume was 18.2 cubic feet for a total volume of 27.4. And that paste to aggregate ratio, that PTA, is 0.50. And what does that say? It tells me, and again, this is a prediction. This is a model, if you will. But it does tell me that there is a nice balance between my paste volume and my aggregate volume. Now, if a mix is too heavy on aggregate, if it doesn't have enough paste, it will be bony. It won't look like this. It won't look like this creamy and dreamy mix that we ordered. And to reclaim or to reinvigorate, to bring the mix back to life, to that creamy and dreamy state, more than likely we've got to add water to it. Now, if you remember back to the last mix or the bony mix, we had almost double the amount of high-range or mid-range water reducer, and then that makes a lot of sense. We're not getting that fluidity, that workability, that finishability from the water or from the paste, so we have to chemical it up. Now, the other thing is, we're talking about a mix that has too little paste, but we can also be dealing with a mix that has too much paste. And while the bony and nasty mix, might not close up on the surface, might not close up in the body, if we're on a slope and we're dealing with a mix that has too much paste, we might see, or we might have a mix that we can't level, that'll keep falling down that slope. That's hard to manage. And again, it might not be the mix that we ordered. So our current mix is at a paste to aggregate ratio of 0.5. Let's look at this bony nasty mix. And I really want to compare the two. I want you to see them side by side. So in the bony nasty mix, we had 170 pounds less of total cementitious. So our volume goes from 3.8 down to 3.0 cubic feet per cubic yard. Now, our rock goes up significantly. 130 pounds for the coarse ag, 120 pounds for the fine ag, and with that, our volume of rock goes up. Now, while our water cementitious ratio stays the same, because we have a lower cement content, we'll have a lower water content. In our cubic foot for water goes from 4.2 to 3.3. Now, theoretically, our air is going to stay the same, but when it comes down to it, when you look at that same governing ratio, that paste to aggregate ratio, when we take up our values, our paste, which makes up our water, our cement, and our air, we have 7.5 as opposed to 9.2, and our aggregate volume goes from 18.2 and it skyrockets to 19.9. We end up having a paste to aggregate ratio of 0.38. Now, our actual was 0.50, our design was 0.50, and our actual was 0.38. And ultimately, that's a change of 24%. And I don't care if you're buying socks, buying a Miata, or working with concrete. Anytime we have a 25% variation from what we had ordered, from what the design was intended, either we're making out like a bandit or we're losing big. And in this case, we're losing big. So hopefully you learned something. I really enjoy this type of concept. What it does require is you have an identification of the mix itself. If you don't know the specific material properties of your raw ingredients, that's okay. You can make some assumptions, but the more transparency, the more information you have, the better you'll be able to predict what your mix is going to look like. And in after a certain time, you'll be able to choose mixes a little bit more carefully and have a better understanding of what the implications are for switching out that aggregate to paste ratio. So thanks for joining. Don't forget to like and subscribe. Ding that bell for notifications. Go, go, great!